In this video, we're going to look at finding the limit of a sequence. We have a sequence defined by a1 equals 1 and an plus 1 is the square root of 12 plus an. And we're asked to find the limit. Well, the first thing to show is to prove it has a limit. So one way to show it is that the limit exists is to prove that this function is an increasing function and is bounded above. So let's do that. So a1 equals 1, a2 equals, well, let's substitute in, a2 is root 12 plus a1 is root 12 plus 1 equals root 13, which is greater than a1. So a2 is greater than a1, and by induction, let's say suppose ak plus 1 is greater than ak, then ak plus 2 is equal to the square root of 12 plus ak plus 1 is greater than the square root of 12 plus ak, which is ak plus 1 is greater than ak, which is and then root 12 plus ak is equal to, well, this is just the definition of ak plus, this is just the definition of ak plus 1. So since a2 is greater than a1 and ak plus 1 is greater than ak, implies that ak plus 2 is greater than ak plus 1. By induction, an is an increasing sequence. So it's fairly straightforward if you're happy with induction. So we've proved an is an increasing sequence. To prove an is bounded above, there's lots of ways to prove this. Let's say consider a1 is less than 10. Well, we know a1 is less than 10. Suppose ak is less, so consider a1 is less than 10, I wrote greater. That's it. So we know a1 is less than 10. Suppose ak is less than 10, then ak plus 1 equals the square root of 12 plus ak, and since ak is less than 10 is less than the square root of 12 plus 10 equals the square root of 22, which is less than 10. So ak is less than 10 implies ak plus 1 is less than 10, and since a1 is less than 10, since a1 is less than 10, then an is less than 10 for all n by induction. Okay, so then we've proven then, therefore, sequence is increasing and bounded above. Therefore, limit increasing sequence bounded above has a limit. Okay, and now to find this limit, let's go back to our original definition. an plus 1. So our original definition, an plus 1 was equal to the root of 12 plus an. So the limit is this. So let L equals the limit as n tends to infinite of an. Okay. Then from this, if we take the limit of both sides of this equation, lim n tends to infinite of an plus 1 equals the lim of n tends to infinite of the square root of 12 plus an. Now the left-hand side, the limit of n tends to infinity of an plus 1 is just the limit as n tends to infinity of an. So that's just equal to L. And the right-hand side, well, the limit of 12 plus an as n tends to infinite is the same as the square root of 12 plus the limit as n tends to infinity of an. And that is also, this is 12 plus L. So we now have an equation in terms of L, the limit, so we can work out what L is. Let's square both sides. L squared equals 12 plus L squared minus L minus 12 equals 0. L minus 4, L plus 3 equals 0. So L equals 4 or minus 3. Well, the limit can't be minus 3 because this was an increasing sequence that started at 1, so it's never going to be in a negative number. So L is 4. The limit of this sequence is 4. And it's pretty easy if you just want to play around with your calculator. You can just put in this sequence, adding 12 and square rooting each time, and you'll see it will converge to 4.